Hey third graders, welcome to lesson 13 part 1. In the next couple lessons we're going to be working with those composite figures that I told you guys about a few lessons ago. And today we're going to be doing that by decomposing into rectangles. Tomorrow we'll be doing the second part of our learning lesson. We know that we find area of a rectangle or a square by multiplying the side lengths to find how many rows and how many columns of squares we're able to lay out on top of the rectangle. But how do we do that mathematically for a figure that looks like this? So today that's what we're going to be working with, and tomorrow. So our first strategy is called the break apart strategy. So when we're looking at a figure like this, we're going to be trying to find the rectangles that make up this figure, and we'll find the area in parts and then add them together. So that is the adding part. So on your homework, I want you guys to take a look at your different shapes here on your composite rectangles. Looking at this first figure here, let's look at this little L up in the corner. How could you find the area of this L? Well, you already see all the blocks on here, so of course you could just count them up. Like you could just count up all the squares, no problem. You'd have
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Okay, so you'd have 12 square centimeters. We know that. But we also know that you guys have to get to the point where you're able to find that without the squares being pre-drawn in for you. So let's take a little look. How can we break this up into different rectangles for us to find the area of? So when I see this, I notice that I could turn it into this rectangle plus this rectangle. I could turn it into this rectangle plus this rectangle. Maybe there's more that I don't see, but for right now, that's a pretty good start. So we're going to use a dotted line to show where we can break this apart into two separate rectangles. So since we're doing this one together, how about we all go ahead and draw a dotted line here to show that we're going to break it up into this rectangle plus this rectangle. Let's write our side lengths. On our first rectangle, what are our side lengths? So here we have 2 centimeters, and here we have 2 centimeters. So we have enough information now to find the area of this rectangle, which would be 2 times 2, which equals 4 centimeters squared. So our area here is 4, and then we could find our area of this rectangle here. So let's write our side lengths. So our side length here is 2 centimeters, and our side length here is 4 centimeters. So our side length is 2 times 4, so our area would be 8 centimeters squared. So now we have 4 plus 8 equals 12. So that was 2 ways to do it, and we got the same answer. So that means that our break apart strategy works. Let's look at our next one, this guy right here. So when you break it apart into different rectangles, you want to make sure that you're breaking it apart into rectangles that are easy to find the area of. So for example, like I wouldn't say, oh, I could see this rectangle right here, which I guess you could do because that would leave this rectangle right here and this right here, but that's pretty complicated. You want to make it pretty simple for yourself. So finding like the biggest chunks of rectangle that you can with the information that you have. So I see that we could either split it here, or we could split it here like the last one where we took the top off. Let's go ahead and try and split it into one giant one and one tiny, tiny guy. So let's do this one together. Okay, find the area of this rectangle, label the side lengths. Find the area of this rectangle, label the side lengths. Find the total area, press pause, and press play when you're done. All right, here's my answer. So this side length is 3 centimeters. This side length is 4 centimeters. So here we had 12 centimeters squared. And here we had 1 centimeter by 2 centimeters. So 1 times 2 would be 2 centimeters squared. So here we have 12 plus 2 equals 14 square centimeters. How did you guys do? And you could always count up boxes just to check your answer. Okay, next rectangle. Go ahead and split this rectangle into 2 different rectangles, and then find a side lengths of the new rectangles that you created. Find your area, press pause, and press play when you're done. All right, so on this one, I noticed that if I broke it up here, I would break it into this part, but then I'd still have this L shape. So you could have done that. You could have broken it up into 3 different rectangles. I noticed though that the easiest way for me to do it would just be to make the cut right here. And so then I would have this rectangle right here and then this big rectangle right here. Whichever way you did it is fine, as long as you followed the rules where I wanted you to show where you cut it and then you did your side length. So I cut it here. And then my first side length is 3 centimeters. This side length is 2 centimeters, so it's 3 times 2 equals 6 centimeters squared, or squared centimeters. And then this rectangle is 2 centimeters by 1, 2, 3, 4, 5, 6, 7 centimeters. So 2 times 7 is 14 square centimeters, but we're not done. We've got to add them up. So we need to do 14 plus 6 equals 20 square centimeters. How did you guys do? All right, go ahead and do this last one. Press pause and press play when you're done. You might need to break this one up into more than 2. Okay, so something that I noticed about this when I was looking at it was that if I broke it up into this rectangle right here, I would have 2 similar rectangles here, and then just this one to add. You could have also broken it up into this long one here and then these 2 short ones. If you cut your rectangle a different way than I did, that's fine. You should have gotten the same area though, and then I can check what you did tomorrow when you turn it in for homework. All right, so if I cut it in this way, I have 2 centimeters here and 1, 2, 3, 4, 5 centimeters this way. So then that would mean that I had 2 times 5 equals 10 square centimeters. Here I have 2 centimeters by 2 centimeters. So I have 2 times 2 equals 4 square centimeters. So just so that my information isn't getting lost, I'm going to start writing it down. So I have 10 plus 4 plus the area of this. Now I know that this equals this, so it's just going to be the same information again. It will also be 10 square centimeters. So 10 plus 10 is 20, plus 4 is 24 square centimeters. How did you guys do? Go ahead and use the back to start. Whenever you look at an area model that's a composite figure that looks like it has more than 2 rectangles put together, I want you to think to yourself, where can I break this apart into smaller rectangles and then find all the missing side lengths that I can? So let's go ahead and concentrate on this first figure right here. Draw this on your paper, write down the side lengths, and then you'll notice that there's 2 missing side lengths, this one right here and this one right here. I want to see if you guys can figure out what those missing side lengths are. Now there's a lot of numbers written, so I want you to understand what the numbers are talking about. Usually the numbers are written next to the side length that it describes. So this right here would be our 6 centimeters. This right here would be our 3 centimeters. This right here, so let me underline that just to make that more clear. This right here is going to be this 3 centimeters in yellow. It's kind of hard to see. This right here is going to be our 3 centimeters here. So see how it's just like written next to it? Remember how crazy it got here when we were writing all of our side lengths? So you just kind of have to pay attention to that. So you're trying to find this one right here and then this one right here. All right, go for it. Give it a try. Press pause and press play when you're done. All right, so on this side length right here, I noticed that it's the same length as this right here plus this right here. So if I added up this plus this area here, which is the same as this, if you imagine that there's big rectangle that this is inside of, like the missing part was like, this used to be a plate of brownies and I cut out this part right here. This would be the part of the pan that was at the top before. So it would be 3 plus 3 equals 6 centimeters. And then for this area right here, it's that same trick. So if I know that this right here is 3 centimeters, then that would mean that this whole part right here has to be 6 centimeters on this side because of our rules of squares and rectangles. So it'd have to be 3 plus 3 equals this 6 right here. So this would also have to be 3 centimeters right here. Oops, I should have written it right there. Okay, so now that we have our missing side lengths, we're ready to break apart our area model. Okay, so we could break it into these two rectangles here. We could break it into these two rectangles here. Let's go ahead and do it this way. All right, so go ahead and find the area of this rectangle and this rectangle. Press pause and press play when you're done. All right, your answer, you should have done 3 times 3. Wow, this is looking pretty crazy now. So 3 times 3 equals 9 square centimeters. And then here for this rectangle, we have 6 times 3 equals 18 square centimeters. So our total composite figure is going to be 18 plus 9, which equals 27 square centimeters. How did you guys do? All right, please draw this on your paper and then ask yourself, where can I break this apart into smaller rectangles? And then what are the side lengths that I'm missing? So if I was looking here, I have this side length, but not this one. So this is one that I need to find. I have this one, this one, this one, and this one. So I have all of the side lengths except for that one. Figure that out. Try to find the area of this composite figure. Press pause and press play when you're done. All right, so the answer, this right here is equal to this here plus this here. Let me use a lighter color so that you can see what I'm doing. So we know that opposite sides of rectangles equal each other. So if this was right here, it would be the same length as this because this would be the same length as that. So this is 5 centimeters plus 3 centimeters equals 8 centimeters. So now when you break this up into 2 rectangles, we have all of our side lengths. So I'm going to break it up here. If you broke it up here, your side lengths would be different, but you should still get the same area as me. So I'm going to do 2 times 8. So 2 times 8 equals 16 square centimeters. Here I have 3 times 4. You have to be careful not to get confused with all this extra information. Notice how once I started doing my rectangles, I didn't need this 9 anymore to actually find the area. So make sure that you're using the right numbers, okay? Don't get confused with all of them. Just be very careful. All right, so 3 times 4 equals 12 centimeters squared. All right, so now we have 12 plus 16 equals 28 square centimeters. Okay, please copy this down on your paper. Try to solve it, press pause, and press play when you're done. This one I need to know this side length, which is 4, and then this side length, which is 3. So 4 times 3 equals 12 centimeters squared. And then I have 2 times 10 for this side. So 2 times 10 equals 20 square centimeters. Now I'm going to add these guys up. So 20 plus 12 equals 32 square centimeters. Your paper, you're going to find the missing side lengths and then use the break apart strategy to find the total area of this composite figure.